All right, here's another example of using our properties of exponents. I'm taking a look here at number 45. Okay, so that's where I'm focusing my attention. I know there's a lot of other great problems on there, but we're going to look at number 45. All right, so let's look at this first parenthesis here. Again, I see that I have an exponent raised to another exponent, or a power raised to a power. So I know I need to distribute the 2 to the 5 and the 2 to the 2. But I also need to put an invisible 1 exponent here on 2, on n, and on the 4 because I need to distribute it to everything. Okay? So I'm going to have 2 squared m to the 10th n to the 2nd power all over 4 squared m to the 4th. Okay, so all I did was I distributed the 2 exponent to the outside, to the inside, and again I have to multiply every exponent, even the invisible ones that are there. All right, let's go and do the same thing to the second set of parentheses. Okay, so I know I have to distribute 2 to the 4, but I have to also do to the invisible 1 on the m, the 5, and the n. Every term has an invisible 1 exponent. So that would give me m squared n to the 8th over 5 squared n squared. So those are all my terms all together. So now let's go ahead and take a look at the purple fraction that I've made. Are there any things I can combine right now? Well, it looks like I have m's I can combine, right? Because they have the same base and I'm dividing, so that means I can subtract the exponent. So I have 2 squared m to the 6th n squared all over 4 squared. That's all I can do for that fraction. Okay, now let's take a look at the red fraction. So it looks like I have n to the 8th and n squared, and again I'm dividing, so that means I subtract the exponents, which would give me, so m squared doesn't change, but n to the 6th now all over 5 squared. Okay, so now I've looked at each fraction separately. Now we have to go ahead and combine these together. So let's multiply straight across. Okay, and you'll notice that m to the 6th and m squared, when you multiply, you add the exponents together. So that's going to give me 2 squared m to the 8th. Okay, and then I also notice I have n squared and n to the 6th. So when I'm multiplying, I add the exponents. That gives me n to the 8th all over 4 squared times 5 squared. And so as far as simplifying, that's about as far as I can go by combining all the terms together. But if I continued, I could do 2 squared, which is 4. So that's all I can do on the top, 4m to the 8th, n to the 8th. And then 4 squared is 16. 5 squared is 25. 25 times 16 is 400. And then if I still wanted to keep going, 4 divided by 400 is 1 over 100. So I'd have m to the 8th, n to the 8th, all over 100 as my final answer. But again, if you got to this step right here with 2 squared, n to the 8th, n to the 8th, 4 squared, 5 squared, I know you'd have a calculator and you can figure out the rest. And that is the basis of how we combine using all the properties of exponents. So if you got there, good job.